Welcome, folks. We're going to be working through the Module 1 content tonight. This is the second session for Module 1, so this is Thursday, October 24th. Our goal tonight is to do a little bit of talking about some of the stuff we talked about yesterday, which is, or not yesterday, but Tuesday, which is we went through the syllabus. So I want to make sure that you guys, if you weren't here, for example, please review the videos from Tuesday. My other expectation is that you went ahead and you installed the suggested software and you have a working coding environment. And then the other expectations are as well, when we provide resources, I kind of hope that you go through these. And my preference would be that you go through those materials before you come to class, right? That would be the pattern. If you didn't, not a big deal. It just makes the process go faster, because if you've read about the techniques, thought about them a little bit, or maybe even have questions about them, when you come to class, you can ask the questions, I think, more intelligently. I will try to explain all the content that's in the PowerPoint that I just downloaded here. But the other thing is before we get into coding or PowerPointing or anything like that, my recommendation for you very strongly, and I do this all to all my like intro level students when we're coding, is a real important aspect of working with technology is knowing how to manage your files. And a lot of people forget this, right? And it's no fault of their own, because we live in this modern world now where all of our operating systems, and I don't care if you're a Mac person or a PC person or even a Linux person, when you go to save a file on your system, doesn't matter what software you're using, you just, the screen comes up, you type in a name, you press enter or click save, and it goes somewhere. And then you might not even know where it's located. And then when you go back to look for it, your operating system helps you find it, right? It's like you said, you can do a search, or it comes up on your recent file list and you find it and load it, right? I will tell you that approach is okay for consumers. We are working to be IT professionals, and IT professionals need to work on a different level. We need to know exactly where our files are located, exactly what they're called, exactly why they're in the folder they're in. And then if I'm looking for something later, I know exactly where to go to look. And you can operate any way you want. When I'm working with my Gateway students down at Gateway Technical College, I do everything in my Google Drive. And I'm going to caution you on this approach, though. If you're using Visual Studio with a cloud drive to store your files, there can be issues, right? Not for the technologies that we're using, but some of the more advanced technologies within that product can have issues with cloud drives, unless you're using OneDrive, which works with it just fine. But even with that one, I've discovered issues. Now, the way that I get the Google Drive running on my system, by the way, is I just load the Google Drive Stream software. WCTC is not a Google shop. At Gateway, we're a Google shop. That's our primary platform for like a big backend system. What you guys might opt to choose your OneDrive that's maybe attached to your student account or your personal account, if you want to use a cloud drive. Otherwise, the other option really becomes storing stuff on your local drive. But what I do want to show you is, like, for example, my Gateway Google Drive. You can see I have folders for all the different classes that I teach, and there's a lot of them, right? And every time I teach a class, like I was just teaching my web programming class, which is a 152-101, and I have my a folder that I put all my work in, and it's not in that location. It's actually here, right? And then what I do is I organize it by all the units or modules, and then whether you're working on a project or a case study or whatever, all my files are inside here, right? And so when I work on anything for my school, it's all in the cloud, and it doesn't matter what computer I'm on, right? So like this looks like a folder on my computer, but it's actually on Google Drive, right? So I can interact with it like I do any normal Windows folder, but it's not actually stored on this machine. The beauty of this approach, of course, is somebody walks up, spills a soda on my laptop. It has happened. My son did it when he was a kid, totally wiped out my laptop. Or if somebody came along and stole your machine, whatever, all my files are in the cloud. I'm not losing anything. I can just sit down at a different computer, log into my stuff, pull my files down, and I'm all good. Right. I do like working with the Google Drive quite a bit for doing my academic stuff. It also frees up hard drive space. I'm not sure how much I have in my Google Drive, probably several hundred gigs, I'm sure. What I do with the WCTC stuff, though, too, because I'm not as comfortable using their OneDrive system, is I do create folders on my local machine here. I call it WCTC. I put it in my documents folder, and then, for example, Intro to Programming, which is this class, I have folders for the work, right? And you can see that. This isn't super well organized, by the way, but I kind of don't care about that. Real frankly, what I should do is probably create a new folder. I'm just going to do it right now while you guys are watching, and I'm going to call it fall. And actually, I'm going to do it the other way around. I'm going to say 2024 fall, right? This is kind of my naming convention. And then as I'm working on stuff, and you might choose to do it this way, you can create subsequent folders for each module. So you can just say module 1, for example, and then all the stuff that you create today can go in there. The other thing that you can do is you can kind of let go of the reins and allow Visual Studio to put it where it puts it. And I'm going to show you where Visual Studio puts it. It's kind of a strange spot. You have to go to your C drive on Windows. I'm not sure where it goes on a Mac, if you're using a Mac or if it's even possible anymore. You go to your user account. There is a folder called Source and then Repos. And this is where all your stuff gets stored. The folder that it'll drop into will depend on the name of the homework. So, for example, if you're doing Module 1 Lab, you might want to call it Module 1 Lab, right? And then when you come in here, you'll find it. Whatever your technique is, that's on you. What you should know, though, is if you store in your documents folder on most modern Windows machine, if OneDrive is running in the background, your documents folder, desktop folder, I think maybe even your downloads folder, I forget which folders, automatically sync to OneDrive. I don't do that on my personal machine. This is a personal choice. I find that obtrusive. I don't like, for example, if I look in my documents folder, I have like my TurboTax. I don't want that going to the cloud, period. I don't trust Microsoft that much, I want to keep my tax files on my own machine. These are personal choices, but the default on modern systems, like if you bought your system within the last few years, OneDrive is probably automatically turned on and your files are automatically syncing. If you find that Visual Studio is struggling with it, you might want to tweak that setting or store your files where Visual Studio wants to put them as opposed to where you want to put them. But in order to find them, once again, C drive, users, your user account. And I know I'm doing this fast, but if you're watching it on video, you can always slow it down and pause. Source folder, repos, right? That's where it puts it. All right. I'm going to change that, by the way. All right. So I'm going to go over to Visual Studio, which I already have launched, and it's at the splash screen. And I'm going to go ahead and create a new project here just so I can sample the code that we're doing during the lecture. You might want to do the same thing. And so go ahead and create a new project. We went through this process last time, right? Now, basically what you see on this screen is a list of project templates that you can choose from. And because this is such a big and powerful product, it has so many options. It's crazy. For example, what language are you coding in? What platform are you coding for? Are you pushing it to the web, or what are you doing with it? Our primary language is C#. So by choosing C# here, and then choosing Windows, and then ultimately, I don't know if it has console, right? And then it narrows it down to the very few, options that you have available. If you chose the console app last time when we experimented on, installing the product, it's already on your recent template. So you can just choose it from here, right? So you don't have to dig through those menus. But the reason they have all these drop downs is because there's so many templates, you don't want to just haphazardly choose anything, right? So I'm going to go ahead and choose the console app, and then I'm going to click next, and now I'm going to name it. And what I'm going to do is I'm just going to call this module 1. I don't know, let's call it lecture. You can call it whatever you wish. It's trying to put it in the repos folder. You see the folder. I know this is probably small on your screens, but I'm going to move it. I'm going to go to my documents folder, go to my CTC folder, intro to programming, 2024 fall, module 1. And then I'm going to call it, well, that's the folder. We're just selecting the folder. Okay. The other box I suggest that you check is this one here. The reason that we check this box is basically we're doing very simple little apps, and mostly to learn the concepts. So putting the solution file in the same directory with the program file is absolutely fine. What this is, a solution file is basically, I think of it as a pointer file that points to all of your project resources. Sometimes when we code applications, it's really a bunch of applications working together. And if I had like 4 or 5 applications in one project, the solution file would be able to point to all of them and bring them all up simultaneously, right? We're not working at that level yet. So if you were, you would uncheck it, right? If not, you just check that box, puts them all together in the same folder, right? The next screen, and I know that you guys are probably looking at .NET 8 on your machines. I think that's what we discovered last time was the install. We're just going to stick with that, right? I don't know if I have that available. I think I'm going to switch to it. And just to be in line with what you guys are doing. The language did a significant shift when it hit version 6, which is it added a whole bunch of new features and also made it platform agnostic. So it doesn't care anymore if it's running on a Mac or running on a PC or a Linux machine. It can do all of it. The other couple of checkboxes that we have here are pretty important ones too. Generally speaking, and I find that these are listed in reverse, and I'm going to click the little box here. No, it doesn't even allow me to click it. But basically, when we're coding a program, we're going to see this in the PowerPoint. Really what we're doing is we're working within what we call a namespace, and that's obscured from us. And we looked at that very briefly last time. We'll look deeper at it today. And in fact, I don't want you guys to do this. I'm going to go ahead and create this checking that box, which I think generally I don't want you to do, but they list it backwards. So I was like, question myself on doing it. But if you check that box, this is what you get on your screen, right? And this is what we call it kind of like the old school approach, which is there's a namespace, which is really just a container with a name. Then we have the program class. Then we have the main method. And the main method in a program is what executes all the code, right? This is great and everything. However, this tends to confuse people when we're first starting out, because mostly when we're writing code, we put it in between this set of curly brackets right here and do all our work in there. So the superfluous stuff is just that, it's superfluous. If I start to write an application that has multiple program files inside of it, and if I start writing GUI programs where I have like different screens and interfaces and oh my God, all these different tools, then I do want to use this, right? This structure. But for right now, to keep it simple, I'm actually going to close my solution, and then I'm going to basically do a new project. Again, you guys don't have to do this, by the way, and basically make all the same choices. And what did I call it? But I'm going to abbreviate this time and say mod 1 lecture, right? Just so I have a different name. It's still putting it in the same folder, which is fine. Solution in the same directory. I'm going to uncheck that box, and then I'm going to click create. And then notice, without the superfluous stuff, Now we're cleaned up. Now we just have straight up code. Right. And if anybody's like coded in like Python, for example, this is how you start out in Python. Right. The reality is those mechanisms are still there. We're just not seeing them. Right. And often in a console application, those are irrelevant, anyhow. Right. I am going to get rid of this thing up here at the top because this is a comment. But let's talk about it first. Let's dig into the lecture materials. And then now we have a working environment at our disposal. All right. Here's our agenda for the evening. It's a lot on the agenda. So you will feel kind of like I'm a football team using a hurry up offense sometimes. There's some things that I'm being sincere here. I'm going to move quickly through some of this stuff. And then some stuff I will spend more time on. Right. And it's really, there's kind of a flow of the PowerPoint, and it is a lot of slides, but there's a process to it. All right. So we're going to start with looking at the structure and the syntax for a program. And when we launch Visual Studio and create a new application, we get this, right? And by default, it throws in a console write line statement. And we already ran this last time, right? And it says hello world. And this is the obligatory first program you're supposed to write when you're learning how to code, by the way. Now, kind of a few interesting things happening here on the screen. You will notice inside of your IDE that you do have line numbers. The line numbers, at least when you start out, you're like, why do I need line numbers? I type stuff in Microsoft Word and there's no line numbers and I can still find my stuff, right? But when you're coding, and right now we got 1-2 lines of code, and then you get to the point where you have 10,000 lines of code, and then you run your program and it points out an error on line 752, it makes it a whole lot easier to find the error. That's the why, right? It's a reference, and ultimately it becomes really helpful. And even as I'm teaching, or like maybe coaching you guys on doing your coding, like if you share your screen, I'll say, no, line 32, yeah, right there, that kind of thing. It just makes it easier to talk to other programmers and to understand the error messages you will get from your debugger that's built within the program. All right, so that's a first point. Now, we are working with those superfluous things, right? And those are technically called top level statements. We're obscuring them just to kind of focus on the concepts right now. But the reality is normally we're working inside of what we call the main method of a program. The main method of a program will automatically execute once the program is launched. So I want you to listen to that really carefully, meaning any of the code that's in between the curly brackets of the main method, that will execute. If it's not inside the main method, it will not execute. So one of the reasons why we omit those, they're still there, they're just obscured, is because we want the program to execute. We don't want you putting the code in the wrong spot and not having it run. This is very similar to other languages of the same style. And keep in mind that the C# language is a variant of C, which is in the family of C, C++, and Java. Those all come from the same place, right? And operate very much the same way. So also telling you that once you learn this language, learning any one of those is super easy. It's just little syntax changes, little different features, maybe a different way to say something, but the concepts are identical, right? So really easy once you learn one language to learn many. And you know what, mark my words, right? If this is your very first language, a few years from now when you're out there working, you'll probably know like 10, 20 languages. And it's like, how'd you learn all those? Well, I don't know. I get the concepts, and then I just need to learn the syntax, so that's a important thing. Another thing that happens is when we're in a program and we're looking at something like this that's prefaced with 2 forward slashes, this indicates non-executing code. So for example, and you will see that as I'm typing it in, it's a different color. And really what this is telling me is this isn't going to run. This is just information for me. So I'm going to say this is just info for me or whoever else looks at it. No. And you can type it in. So if, technically this is a comment, right? Comments can be placed on their own standalone line, or they can be put at the end of a line like this, and it works. But if you're putting it at the end of the line, the double slash technique is the only one that works. There is another approach, which is what we call the CSS style comments. And I want you to see how those are kind of put together. You start with a /* or asterisk technically, close it with a star asterisk, and then you can type as many lines of like stuff you want in between. Your choice. So if you got a lot to say, this is the better approach. If you just have a comment or two, that's an approach, right? I am going to remove these, by the way, and I'm going to just keep one of them just as reference. Right. And I'm getting rid of the default Microsoft one. There we go. That's a comment. Now, in some coding classes, and I have never been a fan of doing this, some instructors will make you put your name at the top, intro to C#. So if you want to do this for your own sake, you could put the date in there, maybe even the name of the assignment, something like that. Feel free. If that helps you, do it, right? For me, I'm not going to do that. I'm not going to require you to do that. That's on you. Okay? You do that for your own sake, not for mine. All right. All right. Anytime that we're adding space inside of a program. So just for example, like I have one console right line that says hello world, and then see it's anticipating what I'm going to type. And by the way, whenever it's anticipating, if you hit your tab key, it'll actually type it on the screen for you. There's a little bit of hesitation initially when you learn how to code to do that, to accept what it's, basically auto typing, but I will tell you that if it's suggesting the right thing, there's no harm done in letting it auto complete your stuff for you. Now you'll notice when I go to run this, you don't have to do a run on this, but I'm going to let it run. All right. And it's going to put those messages up on the screen. And I'll have you notice that when I did my right line statements here, which pushed to the screen, it typed hello world, went to the next line, typed hello world, next line, auto typing. Why didn't it put extra spaces in between? Well, that's what we call blank space or white space in the document, right? And well, I'm in dark mode, so it's like gray space, I guess. Doesn't really matter. But the point is, the spacing inside the code is for my sake. It's not what pushes to the screen, right? So I could, in principle, I could put these all on the same line, right? And I could run this again. It still comes out the same way because basically a console write line prints one line of text to the console. Doesn't matter how I arrange it on my screen internally. Computer doesn't care. It just executes, right? So that's basically blank space. I'm going to close that console window, by the way. All right. Going back to that whole superfluous structure, and if you remember, there was a namespace that kind of will always match the name, either the folder or the project name, right? Everything that's contained inside of it. It's really just a container. The class file is actually the program file. So what your class file is called is the same as the name of the program file. So the class name for this program is program. If it was named something else, program 54 or something like that, then the class file would be named program 54. And then the main method, which is the one that executes everything, is always called the main method, right? And it's got to be named that exactly. Be thankful that you don't have to do that, because like if you, for example, have ever learned traditional C programming or Java programming, man, you have to learn how to public static void main string args semicolon curly brackets, and this is like, I've done Java so many times, it's in my brain, right? But it's not easy to remember when you first start, right? So that's why it's really helpful to kind of skip all that. And I hope you guys feel like that's kind of a good thing. We are using, I think all of us are using the .NET 8 libraries. Technically, these libraries are called an SDK. An SDK stands for Software Development Kit. It's a collection of code libraries that allows us to write the code. Without the Software Development Kit, we can't create the code, right? We're using version 6.0 or above. Everybody here is using 8, I think. But what happens is there's kind of this weird naming architecture for running programs. So for example, we're using the console write line statement, but in reality, the console write line statement comes from the system namespace, and we don't see it, but there's a using statement at the top that says using the system libraries. They're the default libraries for the SDK. And the console write line is code that's inside those libraries that we're calling in. Because system's already declared at the top of our file automatically, we don't even see it. We don't have to say system in front of the command. If that statement was missing, we would have to include that also. So in other words, this points to the system library, the console library within the system library, and the write line method within the console library. That's what it's really doing, right? So it's not just coming from anywhere, it's coming from very specific locations, and the structure of the command is telling you that. Right? There are times when you write programs and you do use using statements, and basically what a using statement does is it tells you which libraries you're pulling in. Because for example, like if you do like advanced mathematical calculations, you might pull in some advanced math libraries that allow you to, calculate logarithms or something like that. And you pull in that library and you just call the commands from that library to add to your code, so you don't have to code it all from scratch. Perfectly normal encoding. So for example, what console write line does to get hello world to the screen, there's code that's written to do that. We don't have to write it. It's already written. We're just using it. Right? That's really what's happening in the background. All right. As we start to write, and commands, that execute code, it really becomes very important to understand that the precision of your syntax is critical. It's absolutely critical. And the point is that C# is highly case sensitive, and this command is not the same as this command. What's the difference? One's got a capital L and one doesn't. Makes them different. And if the library doesn't contain a capital L in this method, it's not going to execute. And what will happen is it will underline red like that, right? So which version do we have? Well, write line, capital W, capital L, right? So if I change it to a lowercase l, see how it underlines red, right? So that tells you that it's wrong. It also changes colors, right? Notice that too. I will have you also notice that it will suggest fixes too. We'll deal with that one step at a time. All right. We already did some commenting, and I think I demonstrated this already. So you can put a comment on a whole line. You can put a comment at the end of a line if you use the double slash approach. or you can use the what I call the CSS style. Like if any of you guys know HTML and ever done like CSS commenting, this is a technique for commenting in CSS. This commenting technique actually also works in Java. It also works in JavaScript. It works in Python and a few other languages, by the way. And it's usually used for multi-line comments. But if you type in a comment and it changes colors, that green text is basically saying this isn't executing, it's just information. Why is it useful? Well, when you write something that's really complex and you step away from it for a while and you come back to it, how do you know what you were doing? It is one thing. The other reason we use commenting, honestly, is because when we're working with other programmers, you might name something a certain way, or you might have a certain way you did things that doesn't make sense to the other programmer. Putting comments in your code is a kind of a way to communicate with others. In the old days, we would get programmers that would refuse to comment their code. Why? Job security, because nobody could figure out what the heck they were doing, right? And then they'd have to call you back and pay you big money to figure it out, right? And that's considered a big no-no these days, especially in team environments. So if you work for a big company where you're working on a coding team, they'll often enforce that you comment everything, in detail. All right. One kind of really interesting aspect of like writing programs is the fact that when we're executing a program, we're writing a set of instructions. And sometimes when we're processing information, to do our input process outputting, we gather information either from the user or from a data source. And then we need to take that information and put it somewhere in computer memory or RAM in the storage location so that we can, retain our data and manipulate our data. And keep in mind, whenever we are going to create storage, we call it a variable. And the name variable says a lot. That means if we store something in a variable, we can also change its value. So for example, if I have like a variable that stores my age, it's only valid for a year, right? And a year from now, I'm going to have to update that. So it needs to be a variable. So when we create variables, we're really what we're doing is we're creating named storage locations. So we're assigning basically a label to a spot in computer memory to store the information. However, when we're naming a variable in this language, we also have to either declare its data type or use the var keyword. We'll look at the var keyword in a second. But for example, if I was storing a counting number like 1, 2, 3, 4, 5, I would first have to declare that it's an int. Notice it's all lowercase. An int stands for integer, which is a counting number, right? And then space, and then whatever I'm naming it, followed by a semicolon. Right now, this is just creating the spot in memory. I'm not putting anything in it yet. I'm just saying, hey, right here, that's where my number goes, right? I also want you to look at how it's named, right? This technique of naming is called camel casing. And what that means is we have kind of like logical words in here. There's a logical word. There's a logical word. The first one starts with a lowercase letter, but every subsequent word begins with an uppercase letter. This is not a rule, by the way. This is a convention that programmers use. So if it was a rule, that means we would have to do it. The convention means this is how people do it normally. Why? Because it's easier to read. Okay. All right. So this declares a data type and a name for the storage location. And whenever I think of a variable, I always kind of use an analogy of like a box or a jar. Like I just created a box and I wrote something on it like shoes, so what's going to go in that box? Shoes, so you can think of shoes as like a data type. In computer memory, we're storing a number here, right? So int stands for integer, a whole number data type, like what you learned when you were a kid, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? It has a name, and please notice that all statements inside of C# all terminate with a semicolon. You eliminate that semicolon, for example, your code is broken. So notice, like right there, it's recognizing that it's broken, and it probably, if I hover over it, would tell me to fix it, but I'm going to just put it back. So if you omit that, the compiler inside of Visual Studio doesn't know where your statement ends. It doesn't know that it's over, basically. So those are both very important little pieces. Another way that you can declare a variable is to use the var keyword. And notice this is more flexible. Okay, so, and let me explain the difference here. I'm just saying that I'm creating this box. I'm giving it a name that implies I'm going to put a number in it, but we really don't know what the data type is until I actually put something inside of it. That's kind of the key here. So for example, the moment I assign a value to the variable, then the data type is set. Now, generally speaking, I prefer this approach, that I know my data type in advance because I planned out my code. But if you're not sure, like for example, if you're prompting the user to enter a piece of information and you say enter a number, you don't know if they're going to type like a regular counting number or if they're going to type like 1.35. You just don't know, right? So this would adapt, and then if it was a floating point number, it would adjust. Another really important concept here is the equal sign. The equal sign in a programming language is not the equal sign, right? This is what we call an assignment operator, right? Meaning, and this is, I like the fact that the arrow is here, because whenever you see a single equal sign, it means that whatever's on the right side of the equal sign, in this case, a number, is being stored in the thing on the left side of the equal sign. So this statement would take the number 5 and store it in computer memory inside that memory box called my number. It's an assignment statement. All right. Now, different approaches to this. So we saw initially we did int my number and a semicolon with nothing inside of it. Here, I could also declare my integer directly and assign it a value all at the same time. So when I'm actually placing a value inside of a variable, the concept is it's initialized. Well, not only did we create it, but we put something inside of it. So we, have the storage space and we're using it, right? And the moment you have a value inside, it's called initialization, or we say it's initialized, right? Now, interestingly, because this is a variable and variable implies change, in the one statement, I can declare the variable and assign it a value, so it's initialized. And then in my next statement, I can change the value. So I had 5 pizzas, now I have 10. My age was 5 and now it's 10. Maybe that's my maturity level, not my age. I'm not sure. Something like that. Somewhere in between 5 and 10 is probably where I'm at. So I know, bad joke. Sorry. All right. So which one should you use? Should you use a variable generically, or should you use the integer? Now there's different names here. So like you'll notice when you use the type that you need to use, we call this the explicit type. We are explicitly saying it's a counting number or an integer. Here we're not so sure, but the moment I apply a counting number to this, it will become an integer, actually. Right. So this is why I'm not really a fan of doing this. I mean, if you're writing a program, you should kind of know, right? But the language does offer it, so it is important to kind of point that out. Another concept that's important too is this concept of what we call a literal, right? So when something literally is what it is, okay? So this is pretty weird. So the concept of, so if I say, hey, that's a numeric literal, that means, well, it's literally the number 5, This is literally 5. This is a variable that holds the number 5, right? If I'm outputting hello to the screen, and notice hello is inside double quotes, meaning it's text, right? That literally is the text, right? So these are weird concepts, and it might be like in one ear out the other. I get it, but you know, this is terminology that's really important. And sometimes the terminology really doesn't stick until you've heard it a whole bunch of times, right? That's how I was when I was learning this stuff. I mean, holy cow. Yeah, I had to hear it many times over before it stuck in my brain. And there's studies that have been done on this. They say on average, a regular adult brain needs to hear things 39 times or something crazy like that before it completely sticks and you remember it. Right. Right. So why do you have all the dialogue from Star Wars memorized? Because I've watched it 39 times. Right. Or Die Hard, I got that one memorized too, I think maybe. All right. So we have like in these slideshows, we have these little try it out things. And if you want, you can go ahead and do this. And I want to actually take this code, and you notice that I'm copying it. You guys can do the same thing, by the way. And maybe I'll even be kind and just drop it in the chat. I don't know if, oh, you guys, I'm not sure you guys can copy from the chat. But I think we had this problem last time, right? Can't copy from the chat. But I'm going to throw that code in here. I just want to show you what it does. Notice it pasted all on the same line. Not good, but doesn't really matter. And I want you to notice that our right line statement is one's a right and one's a right line. All right. And I'm going to run this, and they ask a question in the PowerPoint. And the PowerPoint does include the following statements which contain one logical error, and then we're going to modify it so it fixes it. So watch what happens here back in the program. All right. So I have an integer I'm declaring called value. I'm setting its value to 5. So I'm initializing it to 5. And then I'm going to write a statement. Now, the difference between a right statement and a right line will put the information on one line and then take you to the next line, ready for the next one to print. Right will just write this on one line and wait for the next right line to add the information on the same line. All right, so we'll see that in action. So I'm just going to hit run on this. And the value is value. And I'm just going to pull the output here so you can see it. And so some of you might have thought, well, okay, well, if you're outputting these words, great, because these are just words. But shouldn't this output the number 5? Yeah, it's not going to do it. And here's the why. Because what we really want to do is we want to output the variable. If I put it inside of double quotes, it treats it as text. So now if I run this program, right, the value is 5. So when it gets to the right line statement, it's reading the variable, inserting it into the statement, and then outputting it. Right. So this is the thing we're going to do a lot. Right. And sometimes it's okay to put in a literal. This is a text or string literal, right? Literally is the text that we're putting to the screen. This is taking the contents of a memory location and putting it to the screen. So value on line 9 is not literally the value 5. Up on line 7, the number 5 before it gets stored is literally the 5. Right. So let's see that there's the terminology for you kind of kicking in a little bit. All right. I'm going back to the PowerPoint here, folks. All right. So the point that they're making here is, all right, we use 2 different statements to basically output one line of text. So I did the text with one command and the number with a separate command, right? And often what you want to do is you really want to just be combining it in one statement. So you can do what we call concatenation. And what concatenation means is to join things together, or as it says there, it append one value to another. So I can take the text where the text ends, insert a plus sign. This does not do math here. This is a joining statement in this case, and then append the value, right? So if I wanted, I can go back to the program and I can just say, I can switch this to a right line, get rid of this statement, and then here, add a plus sign and the word value, which will read the memory location, right? And then I run the program and it will do the same thing. So now we are concatenating a string to a number, or a string really to a variable that's a number, and outputting it to the screen, right? So that's called concatenation. All right. Little try it out here. I'm going to skip that one if you guys don't mind. All right. So when you start like naming stuff, you got to start thinking about how you're naming stuff. And the modern trend has become, and I think this is largely driven by languages like Python and JavaScript, for example, is it's better to be overly verbose and exactly describe what is being stored in the memory location rather than name something generically like stuff. Okay, well, okay, what stuff are you talking about? That stuff, the stuff they ordered. Oh, you mean items ordered, right? So that makes sense, right? So the name of what you're applying to a variable describes what you're storing inside the variable. So for example, if I wanted to store my salary, I wouldn't create one called stuff. I would say my salary, or my annual salary, or my weekly salary, or something that was descriptive enough for me when I looked at it later, I would know what it is. It always drove me crazy, but I remember teaching at the Art Institute in Milwaukee many years back. And I had this young guy in my class, and he would like do all this coding. And I think I was teaching him something like PHP or something. And he would just like name his variables, whatever, like whatever hand or finger was on the keyboard, like it was on the letter S, he'd type like 5 S's, and that would be his variable name. I'm like, what is that? And he goes, well, I know what it is. I'm like, you know what it is, but I don't know what it is. So I was like, gave him a little flack about that, but what you name stuff is really, really important. And ultimately, when you come back later to look at it, or somebody else looks at it, it makes sense, right? All right. So when you're naming variables, there are some rules. You can use letters, you can use numbers, and you can use underscores. But you can't start with a number. You cannot have spaces in there, and you can't use any of the words that are reserved for the language. For example, can't use any of these, right? These are reserved words. So these are words that do something inside of C#, right? And there's more. Here's another page of them, right? So you can't name anything this. You can't use those, right? Those are off the table. How do you know if it's a reserve word? Well, I'm just going to give you an example. If I start typing a reserve word, notice how it changed, and it's a different color, that's one of the tips, basically. So, all right. So let's kind of do a little exercise here. Which of these are valid and which ones are not? Valid or not? Yeah, that's good for sure, right? That's regular camel casing, day of week, makes sense. 3D graph, yeah, do a thumbs up, thumbs down. Yeah, not good. It starts with the number. How about June 1997? That's fine. Yeah. Mixture #3. Yeah, not good. Weekday. Now that one, I can't tell if there's an underscore there or not. That's a space, right? Yeah. I think this is the spell checker kicking in here, right? Because that is a space, not an underscore. How about $__score? Yeah. Now there are some languages where this would be valid. Yeah, I think I was talking PHP. This would work in PHP. How about all caps zip.code? Yeah. The the period in there kind of messes it up. The uppercase is fine, actually. Right. Then how about underscore value? No, that's actually good. Underscores are allowed. And you can start with an underscore. Yeah, fun little practice there. Um, so we already kind of touched on this concept of what we call camel casing, right? So whenever you have logical words, the next logical word starts with a capital letter. The reason they call it camel casing is I got two humps in the middle here, right? Like a camel. That's where it came from. I do see people sometimes will also start it with a capital letter. It doesn't really matter. But the reason we use conventions in programming is because, like, yeah, the variable is called weekly sales total. I don't have to look it up. If I follow the convention, I know sales and total will have capital letters in front of them, right? Um, but the language is case sensitive. If I had something named the same thing with a capital W at the beginning, and then I called it from somewhere else with a lowercase w, they're not the same thing. They won't talk to each other. It won't work. Basically, it'll break. So camel casing is a thing. Um, I think that I mentioned this enough already. Like the name of the variable should indicate what it's holding. If it's holding your GPA, well, call it grade point average. If it's holding a zip code, call it zip code. Makes sense, right? Why would I call it, whatever when it's what it is? All right. I think we're going to take a little bit of a break here, you guys, if you guys don't mind. And let's do like a 5-minute break, and then we'll come back and resume. I'm going to step away for just a moment. All right, let's move on. Let's talk about the data types that we can work with in a programming language. And um, we're looking first at numbers here. And we already started with an integer. And I know it's like one of those things that you probably learned in like grade school. Like you probably had a chapter in your math book that was like math with integers, and you're like, what the heck's an integer? And then you learn how to program, and now it comes back to bite you a little bit. But that is like the fundamental, probably one of the most fundamental data types in a programming language is just simple counting numbers. And it's not the only kind of data that we can store, though. In fact, numbers alone, there's many, many different formats in C#. So, for example, depending on the kind of number I want to store, I might have to declare a different data type. And I mean, am I looking at a number that's just a regular counting number, or am I looking at a number that's got fractional information or a decimal basically after it? Another thing to consider is the number negative, or might it be negative, or is it positive? These are, questions that you probably have to answer before you start deciding what data types you're choosing. Sometimes it's implied, but, like for example, if I say, what is your age? I mean, most of you aren't going to type like, oh, I'm 32.749 and, in 24 seconds or whatever. You're not going to do that. You're just going to put in, I'm 34, whatever your age is. And would that number ever be negative? Only if I had a time machine, right? Going full speed backwards or something. Yeah, it would never be negative. So these are things that you kind of are implied basically with what you're doing. What's kind of interesting is that C# actually has a number of different number formats that all use different amounts of memory. So if you know the numbers that you're going to work with are going to be in a certain range and are probably never going to exceed this range. Like, for example, if I was doing an age, the one at the top might be fine. Like who's older than 127? Right? Supposedly some people get past that, but unlikely. you know, and probably they're probably not using a computer, by the way. However, right, knowing the capacity of the numeric formats is sometimes important for efficiency. So, like the integer format that we've been already kind of tinkering with, which is kind of a default, right? Like if a counting number, I just kind of automatically, my brain goes to int. But if I'm writing an application that's really complicated and uses a lot of memory, and it's a consideration to save on memory, right? And this is the kind of thing that like professional programmers do, right? Like they'll write programs and then they'll go through and look at, well, how can I make it more efficient and run faster? Well, this number never gets bigger than this. So maybe I'll switch my int from an int to an S byte, right? And notice the ranges, right? So it goes from a negative number to a positive number. And all of these whole number data types and showing how much information they store have a pretty big range. But an integer cannot hold as much as a long. Long can hold a lot more information, right? But it also occupies twice the memory. And also, if you guys are, mathletes here, notice that all the memory storage amounts are powers of 2, right? Because a computer works on a binary system of zeros and ones, basically, or positive and negative voltages. And all the numbers it inherently generates and all the containers it generates are all based on the base 2 number system. 8 is a power 16, and you'll notice that these are just, 16 is double 8, 32 is double 16, etc. Right? So this is for signed whole numbers, so positive or negative. Then we also have these choices for unsigned whole numbers. So if we know it's going to be positive, we can hold larger values, but they're on the other side of the 0 on the number line. So they're all positive numbers, but it's really the same capacity. But notice they have different names. So there's a uint and an int, right? So this might be relevant. So these are things that you probably will forget about, next week. But if you were doing scientific work, for example, these would be very deep considerations, right? Especially if you try to make your program efficient. So I'm not going to go ahead and code this, but this is something you could try out if you wish. How would you go about assigning these values? So like if you wanted to declare these different data types, so I'll demonstrate one, I'll demonstrate a byte, for example. I would just simply use the same approach, right? I would say byte, I might say age, and would I preset it? Well, maybe I would preset it to 0. But that's as simple as that. It's still an integer in principle, but it'll only go to positive 127 or minus 128. All right. Would I be better? Oh, that's the S byte. I apologize. So regular byte. Maybe a byte is right. So if I'm doing an age, maybe that is the one, because I mean I know there's characters in the Bible that live up to those ages, right? Or like historic legacy figures that supposedly, right, live that long. All right. So they have you do that little exercise, and I would encourage you, if you have the time, to do that, and it'll have you then try to change some of the values. So for example, could I store the number -5 in a byte variable? I do have that one available. I think we already know the answer, but what is the answer? Yeah, no, right? And you see the red underline, and there is an error message that generates here, and I'm hovering over it. And this is basically the what we call the on the fly debugger that's analyzing your code before you try to execute it, telling you what's wrong. And it says constant value -5 cannot be converted to a byte. Right? That's not a very clear message, but it is telling you it's not working for sure. Right? If I get rid of that minus sign, no problem. Right? So knowing those data types can be important. I don't want to spend too much more time on that, but um, here's another concept that's kind of weird. It is possible if you have a bunch of different data types of the same data type or a bunch of variables of the same data type, and you don't have anything to put in them yet, you can declare their values all in one statement. So, or their creation. So for example, I mean, I could just take this exactly and drop it into my code. And let's go ahead and do that. I'll just throw it down here. I've just declared 3 variables, all of the same data type. Notice comma in between. So this is an efficiency. I could also, and do something like this. I could add values to them. That's also acceptable. So that would be, instead of doing a separate statement, right? What I need my semicolons. So I'll leave it up to you how you decide to do it. But notice this one doesn't have a declaration in front of it, so it breaks. You can do them all separately, 3 lines of code, right? Or 1 line of code. So these are little efficiencies that you see, especially as you start to move forward in coding. We also have the concept of literals that apply to numbers. And this is kind of weird, but like this number that's up on the screen, you notice at the end of it, there's a capital L. And this is something we do also in the other C style languages. What this basically does is, because the number is not really as big as it needs to be a long can get really, really long, right? What the system is going to try to do is it's going to try to work with it as an integer to save on memory space automatically. This is kind of interesting. So we put the L in there to make sure that it's treated as a long and occupies all the memory space, because we're anticipating that we will need it, right? That's really kind of what we're doing here. So you can use a lowercase l, but the caution there is lowercase l's in monospace type sets like this often look like the number 1. But check it out and see what I'm talking about. Type the number 1 and then type the letter L. Okay. You can tell the difference, but you know what? If I was reading through the code really quick, I might not, right? So just fair warning, right? And that really applies to, anything. Now, if you do actually start putting large numbers in, one convention we have when we write it out, like in a document or on paper or whatever, is to put commas between every 3 numbers, right? This is a common thing. It does not work in code though. But I get it, right? If you're reading a really large number with no commas in it, it's really hard to go, is that millions or billions or quadrillions or what is it, right? And so what you can do is you can use underscores. That's allowable, and it doesn't affect the number. It's just to make it easier for our eyes. Commas have different meanings in the coding engine. That's the why we don't use it. All right. We do also have numbers that basically, I call them fractionals, right? Or numbers with decimal points, and we have 3 different levels of them, right? So if we have 8 different types of integers, well, here we have 3 different types of floating point numbers. And it's all about how precise the numbers are. Another thing that I'm going to have you think about here, it's kind of obscured in this language, is the fact that when a computer does math, it does it using a base 2 number system. When we do math, we do everything in a base 10 system because we have 10 fingers, right? And thumbs or whatever. We have 10, right? And there's a conversion that happens to go from base 10 to base 2. And sometimes information is either truncated or lost. And so the reason we have different floating point types is when we're looking for precision, depending on how precise we need to be, this will help us. So for example, these are the data types, by the way: float, double, and decimal. Single precision, double precision, and decimal. So like if I was doing scientific work, it's decimal all the way. If I'm trying to figure out, you know, I don't know, the average rate of pay, or something like that, I would, and it's a financial calculation, I'd go with a double, right? If I need to be a little less coarse than that, or a little less precise, we go with the single precision float. And this is kind of an interesting thought. If I was to declare variable types for this, I think I gave away the answer already. One's price, one's tax, and one is total. What data type should I declare? You can unmute and just say it if you wish. Type it in the chat. Either way. What should price be?
Float.
Remember, these are the choices.
Should it be float?
One more time.
Either decimal or float.
Yeah, I'd probably go with double on that one, but it could be either one. Correct. Right. What about tax? If I like, what's our tax rate here in Southeast Wisconsin? Yeah. Google help.
Right.
I mean, seriously, but you know what? Don't wonder. I mean, you have the world of information at your fingertips, and real frankly, as responsible adults, you should know what your tax rates are. I'm just telling you that, because you guys, okay, somebody Google this. What is the sales tax rate in Waukesha County?
%5.
5%. All right. What is the sales tax rate in the city of Milwaukee?
The sales tax rate in the city of Milwaukee is 7.9%. This is a combination of the Wisconsin state sales tax rate, 5.0%, and the Milwaukee County sales tax rate, 2.9%.
I used my little Gemini AI to do that. I didn't want to type all that, but that's kind of interesting. And a lot of people don't know this, and I'm recording it into the video and it doesn't need to be there. But if I go to Starbucks and buy my wife and I a coffee here in Milwaukee, I'm paying like $14 for us to get coffee. I come out to Waukesha County and it's like 13. So if I live like right on the border, where should I buy my coffee? Right. These are kind of interesting thoughts. But a tax rate, how do I express? Okay, so if it's 7.9%, how do I express that as a decimal number? What would that convert to?
A float.
Okay, you're going with a float on that. Like, but in other words, I'm saying like 7.9% would convert to what is a number?
0.0.
7.9% as a decimal is 0.079. To convert a percentage to a decimal, you simply divide the percentage by 100.
Okay, Google,
so
quiet.
7.9%.
All right, so I forgot to turn it off. I apologize, but humorous timing. Yeah, but it converts to 0.079. So how much precision do we need? So these are like, because if I don't choose the right level of precision, I might be under or overcharging somebody. You see, this is why this is important. I would probably, for all of these, I would probably choose double for price, double for total, and decimal for tax. Is how I would do it. Probably. Although I think double, you know what, we have to look at what they mean by levels of precision, honestly. All right, so it says when you type a decimal number directly into your program, C# assumes it's a double data type. So that's the default floating point, right? Thing. If you want to force it to act like a floating point number, which is less precision, you put the F at the end. Once again, lowercase works too. Upper is easier to see. It will basically truncate some of the data though as it's storing it, which may or may not be what you want. All right, I'm not going to do the try it out, so I hope you guys don't mind. Now, we have another weird data type, so let's get away from numbers and start talking about characters. And I'm going to try to make this chart just a little bigger here so you guys can see it. But what you're seeing up on the screen here is an ASCII character chart. And what this basically tells you is like every character that you have. So the glyph is the character that you can type on your keyboard, for example. And that each one of those actually converts to a number. So the way that it works, if you're curious, is every time I press the key on the keyboard, it generates a series of 8 electronic pulses, either positive or negative voltage in the range of like 0.3 to 0.5 volts or something weird like that. Total computer geek stuff, right? So every time I press a key, there's 8 little electronic pulses. And depending on how you put the pulses together, it generates a binary number, which converts to this code or to this decimal number. So every character on the keyboard converts to a number, right? Because how computers work on numbers, not characters, by the way. And so all the characters have value numerically. And when you learn like the Python language, for example, it leverages some of this numeric capability. C# can do it too, which is to treat letters as numbers and then do these really sophisticated sorting algorithms and stuff based upon the fact that they're numeric, right? Anyhow, there is a data type called character, which basically is only capable of holding one single character. And it could be any of the ones that you see here, right? So all of that stuff would be considered a character, special symbols, numbers, letters, periods, mathematical signs, whatever. All of that is a character. So if you know you just need to store one letter, for example, middle initial. Okay, well, that's a dangerous one because some people have middle initials, right? Plural. But like if you just need your first initial, that's a single character, right? And the character data type is capable of holding that. It doesn't hold a lot, right? And so this goes back to what I was talking about, how that table that we were looking at, but the characters really do get encoded in a binary fashion. Often when we're looking at like these codes, these are, and I'm looking at them really carefully here. Yeah, these are all in hexadecimal, right? And how do I know that? Because they use all the regular numbers and then they use A, B, C, D, E, F, right? Which are the extension to make it a base 16 number. Now, why base 16? Because base 16 is a power of 2 again. And why A, B, C, D, E, and F? Because you got 0 through 9, that's 10 numbers. And well, we're out of numbers now. So then if we want to do 11, it's, well, actually 10 would be A, B would be 11, C would be 12, etc. Right? So F is 15. Right? And these are hexadecimal numbers. You could also extend these out, and you can Google this if you wish, and look at this either in a binary format where it's all zeros and ones, or some people will encode it in what we call octal as well, which is base 8. Totally weird stuff. Right? Right. Another weird data type, the Boolean data type. The Boolean data type is one where we look at storing values of true or false. This is really kind of a weird concept, right? It's not a number, it's not a word, it's true or false, right? And you do use the whole word. Notice all lowercase. The way that you declare it is with the bool prefix. You might be wondering, where the heck did that come from? Right. Well, there was this guy named George Boole who was a mathematician, and actually he's responsible for a lot of like the weird set theory that we use now, which kind of led to quantum mechanics and stuff like that. But he developed this concept, whether something is true or false, right? And then you can use that in math to make determinations. And lo and behold, we develop computers, and computers work with binary numbers, which are 0 and 1, which fits really nicely into true and false. if you guys are feeling where I'm going with that. Now, when you do create variables like this, you do it for a reason, right? For example, they have a couple of variable name examples. Like the bottom one says, is remote employee. And I'll have you think about like how that's put together. It's almost put together in the form of a question that we're asking that implies, thank you, that implies a true false data type. So is the person a remote employee? Yes or no? Right? True or false? Pick one. Right? So when you're naming those, you use names that sound like questions. All right. All right. So next thing that we look at is a data type called strings. And I'm always careful with, calling this a data type because I know better also. I mean, we think of it as a data type. In the reality, in a complex language like this, it's really what we call a class structure. So it's an object with libraries of its own. But a string is basically a collection of characters. And so that's why and I know this from the Java language, right, where I first learned it, that the primitive data type that we're really working with is a character, one singular character at a time. A string becomes a collection. It becomes a complicated structure that we think of as an object, and therefore carries a lot of capabilities with it. Now, let's kind of put that little discussion aside. Basically, at this point, when we think of text, like words typically, right? But we could also put numbers in here, by the way. So I could, put a number 2 in there. It's still a string of characters. This is called literal because we're literally putting double quotes around it. The quotes really aren't part of it. It's just telling you that everything inside the quotes is the text or the characters that we're working with. You can also use single quotes, and that you saw that with a character. There's kind of a convention that happens actually when you name a character singularly, you do it with single quotes. When you do a string, you usually use double quotes, but the truth is you can interchange them, right? And there's reasons for that. So this is what we call a string literal. So I can declare a string variable. This one's empty, but I'm set up to hold a value. This one is initialized with WCTC. So this is kind of where they're kind of telling you the class thing a little bit. So when we see string, it's really part of a string class. And notice the string class has a capital S. So nothing you really need to internalize right now, but generally, because it's a complicated structure, we actually call it a reference type, meaning it's a constructed data type as opposed to a primitive data type. And notice we'll talk about it more in module 6, so don't like pollute your brain with thinking about that too hard right now. All right. One thing that we often do with strings is we ask this question: how many characters are in the string? Okay, like how many letters are in your last name? That kind of goofy thing. And therefore, because this is a class structure, we can call a property called length. And you see how we add it. We just say dot length at the end of the statement. And that allows us to get a count of the number of characters. And it does, note this: the quotes around the string are not considered part of it. So if I did this, right, I stored WCTC string inside the string variable called school. Then here I'm declaring a new variable that's an integer that is taking the result of the property. So I'm taking school, which is a string. I'm running this property thing called length. It's returning a number, and that number is getting stored here. So this, if I were to print this, it would say 4, right? Because the length is 4. There's 4 characters in that string. Here's the example. I mean, I just talked through it, but there's what it would look like in code, right? So you want to output it, then you can do your fancy concatenation, right? So, and notice we're taking variable school, which is a string. We're adding a string to it. other thing I'll have you notice is notice that I have to manually force the spaces in here, right? Otherwise, WCTC would touch has. There would be no space in between. Then we're adding that number in here and the character, so it outputs what you see on the screen exactly. Learning to add the spaces when you use this form of concatenation is kind of a little bit of practice kind of thing. Often what happens is you get it to the screen and go, oh, I need to add a space. You see it after usually. You do it and then you see it, which is okay, right? That's how you learn. There's kind of another interesting thought. If you're working with characters in a string and you need to find a particular character in the string, this is really kind of an interesting thought, in that whenever we put stuff in a string, it's a collection of characters, and each position in the string is numbered. So the first one is position 0, position 1, position 2, position 3. So it goes from position 0 to 3, 4 positions, but the highest numbered one is 3 because we start with 0. And that's another big takeaway. Computers always start counting at 0, by the way. All right. Well, if we wanted to access a particular, okay, so I guess the point of this one is this is trying to find the character at position 0. Notice the square brackets here. So what's the character at position 0 that would get stored here? W, right? Right. So then they ask this question. If I wanted to find the last position of this, how would I find that in a number? So enter this other concept, which is, what we call a string method, by the way. The answer would be, how would we find that? What would be the right syntax to put in here? Well, if I wanted the last position, I would just put in the number 3 because I can see what it is. But normally what programmers would do is right here, they would place a statement that said school.length -1. They would take the length of the object and subtract 1 from it to figure that out. We'll learn how to do that, by the way. All right. One of the reasons that strings are classes and not a primitive data type is because we have all these things that we can do with them, all these tools that are kind of built into programming languages. One, for example, is switching things to lowercase. So there's what we call a method. It's a method, which is really a function. It's an internal function because there's parentheses that follow it, as opposed to length, which does not have that. That's a property, right? But what this would do is it would take the uppercase letters and convert it to all lowercase. So small would show WCTC lowercase, right? So we have both 2 lower and we have 2 upper. I think that the intention here was to have 1 uppercase and 1 lowercase, but you can switch things to uppercase or switch things to lowercase. Because we're running this here and storing it here, it does not change the original. That's kind of interesting. All right, one thing that we've been kind of learning, and this one is a little bit more complicated. I'm actually going to drop it into Visual Studio here and paste it in. Here's a declaration of 2 integers. We have one called A, we're putting the number 5 in it. Another integer called B, we're putting the number 8 in it. Now we're outputting it to the screen, right? And we're saying A plus B, so it'll say 5 plus 8 equals, and then we're actually going to do some math. We'll learn about how to do that too pretty soon. And let's run it and just show you that it actually does work. Right, so 5 plus 8 equals 13. Woohoo! Right, very exciting stuff. But the point is, the PowerPoint is calling this clunky concatenation. Why? Because if you were to build this manually, especially if you're fresh to this, you'll probably, like I said, you'll probably forget the spaces, or maybe they won't like line up quite right. If you forget this plus sign, you might have to add that plus sign, that kind of thing. It, in other words, it's really easy to screw this up, right? Why? I mean, just look at it. There's all the plus signs. You got to like kind of keep track of the fact that this one's inside double quotes and that one's not, so you don't screw up your statement. So they have this other approach, which is really kind of interesting. This one's called string interpolation, and this is, a real modern approach. This is being utilized by a lot of languages now. Python, very notably, is big on this also, because what you can do is basically insert this dollar sign at the beginning of the statement, and then take your variables and include them in one large string. So only two double quotes, right? And then the variables go inside curly brackets, and you just space it out like you would a normal thing. So, like, for example, I can take this statement and put it back over in the program, right? And run it. And notice that the output is identical. They're both on the same line because they're both rights. But if this is a right line and that's a right line, you'll notice they both look identical, right? So functionally the same thing. This is easier to put together, and I would call this the recommended approach, at least from my opinion, right? This is called string interpolation. That dollar sign is key. There's also a bunch of formatting commands that you can use. These are kind of interesting as well. Now, if I have a value like this, so here's a thing that might be a calculated price or something like that. There's a calculation that happened and it's an amount. And then if I want to output this to the screen, we have these like weird little formatting commands. I am going to demonstrate them really quick. It's easy enough to do. Just copy and paste it right in. But basically what's happening here is the C is typically used for currency. So that's a currency indicator, which rounds to 2 decimal places. Also notice it inserts a comma and a dollar sign. How nice. Thank you. Thank you, Visual Studio, right? Actually, it's C# doing it. The other one, which is basically a regular number with a 1 after it, that indicates the number of decimal places, by the way. So you see, it does include the comma and a 0.0. And then F, which just puts a floating point number on the screen. Right? Why did it truncate there? Because a float is single precision. That's as far as it goes. Right? It actually truncated the 9-1. I think if I add a 2 on that and run it, it will actually show what actually, I'm sorry, I want to do a 4, not a 2. I don't know if that will work or not. Let's find out. Right, so it tells you a little bit of how that works, but this is a formatting command. It has nothing to do with the data type, by the way. All right, there are a bunch of formatting commands, and here's kind of a little chart if you are curious. Most of the time, you'll be like, if you're writing a program, you'll be told what you want to round stuff to. Currency, that's the easy one. You always use the C2 for currency. Another thing you can do is you can pad your numbers. So in other words, you could, if you want to add like zeros in front of something, there's a syntax for that too. So what we're saying here is, I think, 10 digits with 8 showing or something like that. I think that's what that means, with 2 preceding it, right? So occupied 10 spaces, 8 of them are digits. The blank ones will have zeros. Weird, but some people do use it. Right. Another thing you'll discover is when you're working with variables and you're changing their values, it is allowable because they are variables. So you declare You assign a value, output it, prints 5. Change the value, output it, prints 99. Right, so these are variables. Here's what you can't do though. If I already have a variable name declared, I can't go changing the data type. I can change the contents, but I can't change the box. I already choose on that box, right? So I can't like put books in it, basically. What is a really important concept to understand is that C# is what we call a strongly typed language. Even when you use that generic var, it still applies. So we get this like really weird situation here. So if I have a double and I assign 2.5 to it, and then I try to put that double into an integer, will that work? Okay, this is a really weird concept. But basically, if I'm going to a container that's larger, in other words, it occupies more memory space, I can do that. So I can go from an int to a long, right? That's doable. If I go the other direction, not doable. Or if you force it, because you can force it, you will lose information. So are you ready to lose the information? So generally speaking, you don't want to change data types. So you got a plan basically in terms of like how big of numbers do you think you're going to be dealing with. So just some basic tips on this. There's this like weird hierarchy, by the way, and that's shown with those glasses too. So in other words, you can move in one direction and not in the other, right? So going from a double to an int wouldn't work is kind of the answer ultimately. There's also this thing that we call the cast operator. So like if you need to force it to be a different data type, so if I want it to really be an integer, you use this expression. You basically say int inside of parentheses, and it will force that to an integer. And what it'll do is it'll just get rid of the decimal point, just drops it. Does not round it. It's just gone. How many full ones do you have? 2. Okay, that's what you got. All right, so they talk about this concept of magic numbers. Just imagine a banking program with a line of code like this. Amount equals the balance times 0.068. Okay, so what's the problem with this? What is this? Is the problem? You might not think about that, right? So is it interest you're earning? Interest you're being charged? Is this the tax rate? Is this some sort of like hidden fee or something? We really don't know. And the problem is because the number is hard coded in the statement, if that changes, let's say it's an interest rate. Interest rates change all the time. So now the programmer's got to go into the program, find everywhere where it says 0.068 and change it. Right. So if there's 100 references to it, he's got to change it 100 times. Yes, there are tools that can help you do that, but it creates a lot of issues. So if we have a number that really represents some sort of like fixed value, and I would say like an interest rate is one of them, or a tax rate might be one of them, we have the ability to take a value and kind of lock its value. And we use this thing called a constant, right? And here's the keyword for it, const, which is saying that we're still making a variable. Okay, excuse me, a constant. It's not a variable anymore because we can't change its contents, right? So it's still a double and we're still giving it a value, but with this keyword in front of it, that value is not allowed to change. And then anywhere in the program I write my code, instead of saying 0.068, I can just use interest rate. And then I'll have you notice the other convention with naming constants. With constants, the convention in programming, and this crosses languages, by the way, is to name it all uppercase. And instead of using an uppercase letter for the next word, you put an underscore in there. Why? Because then when you're writing code, as soon as you see a word written like this, or a constant written like this, as a constant, just because how it's named. Oh, that's a constant. Got it. It's just one of those kind of weird things. So you would not be able to do this, by the way. So if I set it, I can't then change its value. Not allowed. All right, let's keep moving ahead here. We got a bit more material to do, and I still want to try to get to some coding. So let's see if we can employ our hurry up offense here a little bit. Some of this stuff we've already played with, so we're going to kind of go through. There's the console.write command. We started with write line, which is it prints one line and then the other. Console write prints on one line and then stays there, and then prints the next line will print right on the same line, right? So prints on the same line, prints on one line, then moves down a line. There's also what we call escape sequences. These are kind of interesting. Once again, somewhat of a language universal. So true in Java, true in Python, true in JavaScript, for example. And basically we use a backslash. The backslash is above your enter key, by the way. If you don't know where it is on your keyboard, a lot of people don't. And then you use like one of these characters. So for example, if I insert this into a write line statement, I can like write a couple words, put in an escape sequence, write a couple words. The words after the escape sequence would be on the next line. So this is kind of like hitting enter in the middle of the write line. If you want to insert a tab stop, which is like usually 4 or 5 spaces over, you can do /T. Okay, here's a tough one, right? Because you're putting this inside of double quotes. What if you actually just want to put a backslash in your text? Well, then you have to do 2 backslashes because the first one's ignored, right? That's one of the catches with using the backslash as a symbol. Also, if you're inside of double quotes and you want to put a double quote as output inside of your double quotes, you also have to put a slash in front of the double quote. All right, so those are escape sequences. If you want to try it out, so the little challenge here is to do this, right? Let's put it in there. And what we're trying to achieve is after sellers, a new line, then a tab stop, and a tab stop, right? And a new line and a new line, right? Okay, so let's see if we can do this. So \n, then a \t, \n, \t, and I think that pattern just continues like that, right? So I can copy paste that. All right, let's see if that works. There you go. I still have that other stuff in there, but basically it works. Since we work in an electronic age, like you guys can screen capture my stuff, right? If you want to take notes or, just watch the video later. All right. Now we're going to worry about user input. Like, hey, could we write a program where we ask people for information? Yes, we can, right? So we do call that a prompt typically. And okay, so when we do that, really, it's basically in the form of doing an output statement. However, usually when we're prompting, and you know what, let me just copy this one, right? And let's put it in Visual Studio here and run. So yeah, this isn't really a good example, but here, if we're doing a write, when we end the program, the cursor is going to sit right here in this spot and keep flashing, right? Waiting for the next thing. Now, of course, it didn't wait for us to do anything because we're not capturing any information, but that's where we expect to be. So we don't use write line for prompts, we use write. It's kind of the general point. All right, moving on. So how do we capture that input? Well, then we do this. We say, we set up a variable, right? Give it a name. And then we say console read line. So when the person presses enter, we will capture whatever the keyboard buffer is and then store it in that variable as a string. Right. And then to prove, oops, that we captured it, we can right line it. Thank you, auto type. So we captured it, stored it, and printed it back on the screen. Pretty slick, right? Makes me want pizza. All right. Another kind of issue here is, all right, well, what if I'm asking the user, enter the number of pizzas? All right, here's a weird concept. Whenever we are putting stuff on the screen or receiving stuff from the user from the keyboard, it is always text. So if I ask a question of them, hey, enter the number of pizzas, and they type the number 5, it's actually coming in as text, right? So even if the user types 5, it's read as a string like this. This is a weird concept to kind of latch onto initially. So this actually would not work. That's the point. That statement would not work. So how do you do it, right? Here's an alternative, right? Basically, and they're showing you all the stuff that doesn't work first before you do the conversion. Here's another one where they have a pay rate, and some people are like, well, you can't just convert it from a double, like if this was an integer or whatever, I could maybe convert it, right? Because it was already a number, but this is text. So this wouldn't work either. This is weird, right? So the way that you have to do it is you have to run these commands that are these conversion commands. So we're reading it in from the console, and then we run the conversion command on it. And I want you to notice to int32, that also declares the memory size, right? And then we convert. So we're converting to int32 from the read line. And so I could, in principle, take this statement and run it. So here we go. So I captured it and it put it back up on the screen. So once again, if you want to do a little side-by-side comparison here, right? But this is taking it from the console. It's still doing the read line. It's reading it in as text. And then it does the conversion to an integer data type so that I can store it. So if you're expecting a certain kind of information, then you have to set up the data type to receive it correctly from your user. There are a bunch of different conversion things here, by the way. So these are all the different things you can convert to. So you convert to Booleans, bytes, characters, date, time, decimal, doubles, ints, and strings, basically. I'm sure there's probably a few more methods they're not including there, but those are the common ones to use. All right. This is kind of a weird thing too. So read line returns a string, but we can use the 0 inside of square brackets to just retrieve the first character of the string. So for example, if I ask the user, confirm your order, yes, no. Okay, so what if they type YES or no or NO, right? That's 2 characters. But the first character of each one is still correct. So I could let them type in whatever they want, and it'll only capture the first character. Kind of cool, right? Very, very helpful little thing. Right. Here's another concept, and this gets kind of into the theoretical here, and I'm sorry, because these are kind of heady concepts, real frankly. And it's warning us. It says, are you noticing some warnings about null references? And you guys won't think about this until you get one in the program you're writing, by the way. So for example, we're asking for a pizza topping, we're doing a read line and storing it. And then Okay, are we getting any warnings about null references? I didn't notice any. Are we getting, oh, well, there's an underline here, right? All right. There is a little, it's not really a warning. It's more of a, hey, check this out. But it's telling us um, that basically look at the very bottom of that screen, converting null literal or possible null value to non-nullable type. Okay, so this is a suggestion it's giving us. So what, and we're about to read about this here. Um, so we asked the question, it doesn't matter which one, it is possible that it might throw that error. So basically what this is saying is if you don't put something in a string when you first create it, and then we attempt to use like a length property or something, we get errors and it wouldn't necessarily run. That's kind of the point. So if I drop that code from the previous page in, especially this piece of code here, I think is the problematic one, it wouldn't run and it would throw this thing about null references, meaning like you don't have a value here. So it does not make sense for me to determine the length of something that doesn't have a value. So if you don't go and give this a value, this is problematic. So what they do is they basically have like a little workaround for this, right? And I want to get to the solution for it basically, which is to add a question mark after the string declaration, which allows it to be empty so that the program can still run, right? Assuming the user is going to type anything in. And if they don't, it won't completely break. And this is one of those things that when it's suggesting it, you should probably do it. It doesn't always stop your program from running, but sometimes it can also have catastrophic effects, by the way. The other thing they're pointing out is whenever you use the var keyword, it automatically is making it a nullable type, which is one of the reasons why people do use it. And they do the same thing with characters, right? So we'll see that, you know, and it really what's going to happen is as we start getting into the code here, folks, that you'll start to learn how to deal with all the error messages that are generated, and that's a perfectly normal part of this, and you learn to flow with it ultimately. I love this graphic, by the way, of the old Altair 8800 computer. That's one of the first personal computers you could buy retail. Notice the fancy screen, mouse, and widescreen display. Yeah, no, that was the machine right there. You're looking at it. There was no keyboard or anything. Those are all add-ons. All right. Anyhow, let's keep flowing here. All right. Another thing that we have to talk about, and we're getting there to the point where we'll be coding in a little bit here. There's operators that we also do. So we're going to have to do some math. They talk about a few different forms of them: the unary, binary, and ternary operators. Okay, we'll take these all one at a time, so don't worry about like memorizing that terminology necessarily. The basic math operators all apply, and maybe not in the form that you're used to. Addition and subtraction, those are kind of no-brainers, right? Multiplication on a computer keyboard is the asterisk, and division is the /. But we also have this one that's used a lot, which is called modulus, and this is remainder division. So we do a division statement, and we're not looking for the result. We're just looking for the remainder, like how many times the whole number did not go in. So for example, if you look at like a traditional, you know, division problem longhand, right? And you realize that 5 does not go into this number evenly, that there's a remainder of 3, the modulus operation would just give me the 3, right? The first thing that when people encounter this, they go, well, why the hell do you need that, right? And this is why. This was developed because people tried to figure out how to use computers to make change, right? Like somebody buys a candy bar for 79 cents and they give you $1. How much change do you give them in which denominations? You know, and that's the algorithm requires that you divide by the coin amounts and then look at the remainder to see how much is left over to try the next coin amount, right? So It's a really interesting little algorithm. There is an order of precedence in math. So if you guys are currently taking math, which is possible, or if you were mathletes perhaps at your former existence or high school or whatever, you know that there's an order of precedence. And kind of the point here is if we're looking at these numbers and adding them straight across, doesn't matter which order we do this in if it's addition. Yeah, not one little bit, right? If I'm now throwing in division or multiplication, well, we're doing division first, right? If you read it right to left and you add this and it's 18 and then divide by 3, your answer is 6. But if you do it correctly and divide the 3 into the 6, that becomes 2. And if the answer is actually 14. Yeah, which is correct. The bottom one is correct, right? Do you guys have you guys heard of that like PEMDAS thing, right? Like from your math classes and stuff, or maybe not, or maybe you forgot. There isn't a precedence. So for example, what does this evaluate to? Anybody?
Is it 6?
6, correct. Why? We do this first. It's 6. 6 minus 6, 0. Plus 7, 7. Minus 1, 6. Correct. Very good. Now, the computer will do that automatically. It'll do this one first. But I always tell people when you're coding, if you want to force something to happen a certain way, or you're not sure if it's going to happen the right way, put parentheses around it is really kind of the grand thing. There's really good information here about this, but I'm going to kind of fly through it. I think it seems like you guys are pretty on board with it, but it shows you the order of precedence in this language, right? And you have what we call unary negation, which means when you put a minus sign in front of a number to indicate that it's negative, that's unary negation first. So that's always handled first. Little practice here, right? We came up with that answer without writing it all out. Parentheses are highly recommended to force the calculations to happen the right way. We also have this other operation called integer division, and this is kind of weird. So if I do this particular math, right, if I divide 2 into 5, the answer should be 2.5. Like that's what a calculator would say. But if I run this and output it, what will I get? Yeah, I'll get 2. So if I want to force it to actually do decimal places, I have to convert one of them to a floating point number, because otherwise it's like, oh, you're dealing with integers, you don't care about decimal points, so whatever, right? If at least one of the values is a double or a decimal, it will do the work correctly. All right. Another thing that we talk about are cast operators. It's also kind of a way to force it to get the right answer. So for example, okay, what this is saying is got an int, oops, I don't want to do that. We got an int, we got an int, right? We divide and we try to store it in a double, but it's going to store 2.0, right? 4 goes in there twice, the remainder is ignored, right? So what we do is we can force a cast this way, right? Because we might not be able to change the value of the variable, but we can control the value as it's going into the equation using the casting. So kind of one way to do it. Another thing that's real common when we're doing programming, and this is an important one because it's something we use pretty much right away, is often we're trying to count things or keep track of things. And so I can set up a counter variable, call it count, set it to 0 because I don't have any count yet, right? And then every time something happens, I can add 1 to it. So I could write a statement like this: count equals whatever count was plus 1, right? That's kind of one way to do it. Now you can add a value or you could subtract the value, right? So you can do that with the statement that we just looked at, but they also have this shorthand technique, which I think is, I always just say plus equals, and that's how I express it. But this statement down here essentially does the same thing as this one up here, right? So if I want to add one to the count, I can just do count plus one. If I want to subtract one, I can do minus one, by the way, right? So I can do plus equals, minus equals. I can also do multiply, divide, modulus. The bottom three get pretty hairy though if you can't reason your way through it. And I'm just warning you, right? Typically, these two get used a lot to increment or decrement a total. These are a little trickier. Not that they're not doable, but you better know your math really well first. Is what I'm saying. It's easy to screw those up. All right. So just doing all the rewrites on it. And folks, that's the end of the PowerPoint. Thank God. I hope you guys are feeling the same way. That's a long one, and I'm sorry. This is probably the longest one of the whole course.